my paper and Dr. Jivan paper, I'm not sure. The value is at examination hall. I believe the international student, you know where is the visa units, right? Yeah, the same building with visa unit. Okay, so it's just across the road here. Okay, that is our examination building, not at Block U. I think those I think last semester, I think you never have exam in examination hall, right? It's all at Block U. So I think this time you have to check very carefully. I think for elective will be at Block U. Am I right? But my paper is at examination hall. Okay. So yeah, visa units. I don't know. I don't remember. Do you know which hall? There are 3 halls. Okay. One is just next to the visa unit. Another one at level. Another 2 at level 1. Okay. It's just one of the 3 halls at examination building. For local students, do you know where is the exam building? Okay, it's just cross the road here. Okay, yeah. So yeah, make sure you arrive you know, at least at around 8:15 because our exam will start at 8:30. Okay, so yeah, you can bring your lecture note. Okay, and yeah, no electronics devices. You can print anything. Okay, you can bring a trolley of books to go in. Okay, yeah. So up to you. Okay, yeah, but just no electronics devices. And your bag have to leave outside the hall. You cannot bring your bag inside the hall. Okay, yeah. And the hall actually is quite big. There will be multiple examination at the same time. So make sure you go to the right door and wait. Then you will go to the right place. Otherwise, you have to walk across the whole hall, you know, to get to the our seat. Okay. Yeah. What else you want to know about the exam, except the questions? Yeah. Yeah. I give you a what? I thought I already given you. Sorry, the topics, right? The coverage of the final exam. I thought I already given you all. So yeah, this one. Okay. You will have 3 questions. Question 1, 2, 3. These are the 3 questions. Okay. Question 1 is 20%. It's on time series analysis. Question 2 is this final exam. Question 2 is on text analysis. And then question 3 is 30% is on deep learnings. Okay. So total here is 50%. I will do revision today and next week. Okay, yeah, I will do revision today and next week. So yeah, you will have some activities today and next week. Okay, yeah. Yeah, okay. And when is the submission deadline for assignment? 10th of June. So Mondays, right? Okay, so by Monday. Okay, yeah. So okay. So yeah, no question. Let's start our lecture today. Our lecture today also not very long. So this week and next week's our lecture is not very long. It's quite short. Okay. Then I will have time to do some revisions with you. Okay. So yeah, this 2 weeks we are going to talk about 2 very fundamental deep learning models. Okay. So 2 very fundamental deep learning models. So and yeah, these 2 models, as I said, is the most basic, the most fundamentals. So and after that, there are some more advanced models, but basically they built on top of these 2 models. Okay, but we are not going to cover very complicated deep learning methods because that is really quite deep. Okay, so yeah, there may need another subjects of 14 weeks to study deep learning. Okay, yeah. So that's why. I think last week we talked about, you know, the difference between the conventional data analytics and as compared to big data analytics. Okay, so for the big data analytics, because the data is huge, so basically there are some, for example, pre-processing, for example, storings of the data, even the trainings of the data are quite different as compared to the conventional machine learning method. Okay, so when it comes to deep learnings, the term deep learnings basically is from neural networks. Okay, when we have more and more hidden layers in the neural networks, we call that is deep. Okay, yeah, that means, or actually in other words, they can dig deep into the data set or the data to obtain the hidden features. So that's, we can understand the data or the patterns, or the features better. So that's why the deep learnings. Okay, so also I think last week we talked a little bit on the history or the evolutions of deep learning. So everything starts with artificial neural networks, okay, or we call the ANN. Okay, so again, like I said, the ANN concept is not new. It's in 1940s. Yeah. Okay. Yeah, and then even 70s, it become popular, and then after that, not much evolutions until the last 10 years. Okay, we see the evolution of deep neural networks. So it's all from the artificial neural networks. So in other words, actually, what is a neural networks? Actually, they try to understand our brain. Okay, so they try to understand our brain, and they try to model our brains, how it's worked. Okay, so yeah, of course we don't know how our brain works, but some experts, they already start to not start lah. Okay, they have analyzed, and they have some basic ideas on how the brain works. So basically, our brain is very much depends on the neurons. Okay, so if you have more neurons interconnected, then you are smarter. Okay, so I'm not sure you watched a movie called Lucy. Yeah. Oh, I thought you were very young that time, before you were born, right? I think that movie also about 10 years already, right? Yeah. So you see, when your brain is more and more connected, you become smart and smarter. And at the end, you become a pen drive. Okay? I think you didn't watch the movie, so you don't know the jokes. Okay? So, sorry? Yeah. At the end, she become a pen drive. Okay. Yeah, to me that is a joke. Okay. Yeah. Yeah. If you don't, you can watch the movie. Okay, it's talk about yeah, some science fictions lah, but to some extent it's true. Okay. Yeah. So yeah, so they try to mimic the behavior of the neurons. Okay. And then they try to make it a mathematical models, so that we can train the artificial neural networks to provide some intelligence, some human intelligence to the machines. Okay, so that is the basic idea. So, but when you look at that's why when I started to learn about neural networks, I really cannot understand. So this is a very simple mathematical models. Okay, a very simple mathematical models. So you see, you have input. So all this x1, x2 until xn is input. Okay. So, and then all these inputs are related to some weight we represent with theta, sorry. Okay. And then this is just a summations, function. That means you sum x1 multiply with theta 1, x2 multiply with theta 2, and so on. Okay. And then you include the bias here, you include the bias. So it's just another input you can imagine. Okay. And then you just sum them together. And then you use a very simple activation functions. Okay, you use a very simple activation functions. I think the most simplest one is the sigmoid functions. Okay, we use the sigmoid functions. Okay, and then yeah, the neural networks, the neuron is just like this. Very simple functions. You can do it very simple. But somehow when you have many neurons, they are interconnected to each other, okay? And you organize them according to some structure, okay? Somehow, like miracle happens, okay? Yeah, it can learn non-linear behavior. Okay, it can learn nonlinear behaviors, which is very important in our daily tasks. Okay, yeah, our daily task is always nonlinear. Okay, so that is why miracle happens when you interconnect them together. So basically, this is how yeah, we connect them. Okay, yeah. So yeah, so basically neural network with more than 2 layers. So we call it a deep neural networks. Okay, but of course, this is the definitions maybe about 10-20 years ago. Like I say, you know, for my for my master degree, I use neural networks, but my neural network only 3 layers. Okay, input, hidden, and output layers. So during the time we call that just artificial neural networks. So during the time also they have some multi-layer perceptrons that is even lighter, simpler. Okay, so actually during the time also we can implement multiple layers. But the knowledge during that time is that, you know, there's like no point to implement more layers. Basically, one hidden layers is quite sufficient during the time to perform the task that we want to do. Okay, so that time we do a lot of prediction models. We do a lot of you know, one of the research that is very active during the time is the facial recognitions or the handwritten recognitions. Okay, it's quite sufficient for you to use only one layers during the time. So eventually, yeah, it gets saturated there. Okay, so because they don't see the meaning of having more and more layers. Okay, so in recent years, they see that by using more layers and they design the layers differently, they will introduce different type of layers that we will see later. Okay, and then again, miracle happen again. Okay, so it can learn even more complicated tasks. Okay, yeah, so now when we talk about deep neural network, it's not just 2 layers, 3 layers. It's really, you know, I would say there will be up to millions of parameters in your models. Okay, yeah, so I think last week or last 2 weeks we talked about the ChatGPT, right? The chat models. So you can see the ChatGPT model, how many billions parameters are there. Okay, so it's a huge model. Okay, so yeah, what are the mechanisms in neural networks? So it's very much the same mechanism. Okay, so we start with a training set of input output. So the training set will contain input output, and the training involves changing the parameters of the models. So at first, you still have to decide on the models. For example, you know, how many layers? How many layers? Okay. And at this stage, we just assume all layers are the same. Later, we will see there are different type of layers. Okay, that they can perform different tasks. And then how many neurons in every layers? That will determine your weight parameter, so the data. Okay, so that's why we represent the neural networks with a function of input and data. The data is the weight or the parameters. Okay, or the parameters. So the first process is called feed forwards. Okay, feed forwards, that means from input to output. So it's just the calculation. Okay, it just involves calculation at every node. Okay, from the input or from the left to the right. Okay, so that is what we call the feed forwards process. Okay, yeah. So that's why sometimes, not sometimes lah. Okay, there is what we call a feed forwards neural networks. That means they only contain one directions. Okay, so it's just from the input we do the calculations and then the output. So that is a feed forwards models. Okay, so yeah, and then yeah, this is just example calculations. So actually it's a very simple calculations. Okay, so it's a very simple calculations. So let's say yeah, I have 2 input here. So this input is 1, this input is negative 0.5. Okay, and then I have, this is the parameter, this is the weight parameter. So 1.2, 2.1, 1.5. Okay, and then this is negative 0.3, negative 0.7, 0.3. So this is the weight parameters. Okay, yeah. And then this is the weight parameter for this part. Okay, so that's why this is data 1, this is data 2. It depends on the layer. So this is very much, you can imagine it's like a matrix. Okay, so it's like a matrix. So you calculate the S1 here. Okay, you calculate S1 here. Okay, so it's just the sum. Okay, it's just the sum. So 1 multiplied with, this is 1.2, 1 multiplied with 2.1, 1 multiplied with 1.5. You just add them together. Okay, you add them together, you get this 1.3, 2.45, and so on. Okay, and then in this case, I implement a sigmoid functions. You just substitute the x into here, calculate the output. So the output is here. Okay. After that, you repeat at using data 2 here, then you will get these numbers. So you can see, you know, it's just a mathematical numbers. Okay. So it's involved. This is very much like a matrix multiplications. Okay. So it's quite easy to code if you want to code neural networks. Okay. So it's quite easy to code for these very simple models. Okay. Yeah. So yeah, after that, you know, from here we will calculate the error. We'll calculate the error. Okay. So most of the times there are many ways for you to calculate the error. You can use a mean square error. You can use a root mean square errors. You know. So the ultimate objective is you want to compare the value you calculated with the output. So in this case, it's a supervised learning. Okay, it's a supervised learning. You need to have output so that you can compare the output, and then you will calculate the errors. Okay, yeah. So yeah, our objective here, of course, is to minimize the error. Okay, so how to minimize the error? The most common method is called gradient descent. Okay, descent. Okay, so yeah, or stochastic gradient descent. Okay, so these are the method that we are commonly used to reduce the error. Okay, so yeah, in other words, okay, you can see gradients. That means is the slope, the deviations. So we want the deviation to be smaller and smaller and smaller. Okay, so that's why you can see in every iterations we try to make it closer and closer to our target. Okay, so of course I will not go to this very complicated mathematics. So basically it's just based on the gradients. Okay, we want the gradients to be the slope to be fast and converge to the target that we want. Okay, so you just imagine this is the target, this is the output y. Okay, so for every iterations we want the x we want the calculated y closer to the expected value of y. Okay, so that is the gradient descent. So yeah, so after you calculate the error, what you do? Okay, some models, they do not have back propagations. Okay, so they just use some other methods. But the most commonly used one is called a back propagation. So this is the third step. Okay, so I didn't highlight. Okay, yeah, I should make it consistent. Okay, so you minimize the error, step 2, and your step 3, you do back propagations. So I think from the name back propagation, you know that means it's from the output, you calculate the error, you propagate the error back to the input so that you will make adjustment to the weight. Okay, so this is how you can see from the output, you back propagate the error. Of course, you use all these equations, don't worry, okay, to calculate the error, and you back propagate to the input. So along the way, you will adjust the data, you will adjust the weight. Okay, so you can imagine every iteration is you do fast feed forwards, calculate the error, feedback, and then along the way you adjust the weight, and then you train again, and then you go back again. Okay, so every times you will adjust the weight so that you know, so that your expected value is closer to the target value. Okay, so this is ideal case lah. Okay, sometimes you will achieve some fluctuations. Okay, sometimes you will achieve some fluctuations, but that is fine. Okay, so it depends on how you stop the calculations. Okay, so yeah, along the way you will do parameter update. So this is how you update lah. Okay, yeah, and then yeah, this is what happens? I think this is the second round. Okay. Yeah, this is how you do the update. Okay. So yeah, again, we are not going to study the mathematics. So unless you want to code, okay, but there's no point for you to code a very simple neural networks. Okay, it's there already, the code. Okay. So yeah, so I don't do coding as well. So the idea is like that. Okay, so it's quite simple. Okay, you have the training data, input, output. You put the input to a models. You have to design on the model. You have to decide on the models. Okay, and you will ask, what is the weight that I should put? You can just randomize the weight. Okay, because later they will learn. They will learn. Okay, so the starting's initial value is not important. Okay, so you will do feed forward. You will do calculations and then calculate the error. You back propagate the error, and then along the way you adjust the weight. Okay, and you repeat. Okay, yeah. So yeah. So do our brain learn like this? I'm not sure. Okay. So, but this is how they models it. Okay. Yeah. So yeah. So you can see this type of connections, the initial models. Okay. They call this a fully connected layer. They call this a fully connected layer. That means um all nodes, okay, is connected with all other nodes in the previous layer and all other nodes in the next layer. So that's why it's called fully connected. Okay, so you can see a node in the middle will connect with all the nodes in the input. Let's say it is just 3 layers. It will connect with all the nodes in the input layer and will connect to all the nodes in the output layer if there are more than one. Okay, but in this case there's only one. So that's why later they give a name called fully connected layer. Okay, yeah. So what is the problems with fully connected layers is that, okay, so the first one is computational complexity. You can see every node is connected to all other nodes in the previous and the next layers. Okay, so there will be a lot of parameters. Okay, so yeah, so this will lead to a high computational complexity. Okay, yeah. And then make the model training slower and then require more memory. Okay, yeah. And then fully connected layer also very prone to overfitting. There are two terms here. One is called overfitting, one is called underfitting. Okay, underfitting is like, you learn some things but you are not learning it completely. Okay, so that's why usually we look at underfittings using the training models. Okay, so you train using the models. Okay, and even after that you evaluate using the same training set, the performance is still not good. So that is underfitting. Okay, so that's why if I teach you this, if in the exam I came up the same question and you cannot answer, you are underfitting. Okay, yeah. So yeah, overfitting is I teach you this and you can only do this. I give you some other question you cannot do. So that is overfitting. So you only learn what is in the training set. Okay, so the model is not generalized, it's not robust enough to learn, not to say to learn, okay, to how to say, to process data that they have not seen. Okay, so that's why my teaching is try to balance between underfitting and overfitting here. Okay, yeah, and I will more focus on a good models, that you can solve my exam questions that you have not seen before. Okay, yeah, that is what we want in AI models. Okay, yeah, especially for master degree, like I say, yeah. So yeah, fully connected layers always have these overfitting models. Okay, so that's why sometimes we will do something at the fully connected layer. That means we will do dropout. We will drop some of the connection that is we feel not or less important, so that it will become what the term partially fully connected. Okay, yeah. So we do that to avoid overfitting. I think last week we talked about that, dropout and some others regularizations, okay, to avoid overfitting. Okay, yeah. Yeah. And then limited local connectivity. So you can see each neuron is connected to every neuron in the preceding layers. Okay. So this results in limited local connectivity and ignore the spatial structure or pattern in the input data. Okay. So because we treat every input independently, so that's why we do not see the interconnections, the relationship between the input. Okay. So that is one main problems in the neural networks, because you can see here, okay. So this one, they would take the input from, for example, input 1 and input 2. You can see it's independence. Input 1 multiply with the weight, input 2 multiply with the weight, and then they sum them together. So that's why they ignore the relationship or the spatial relationship between the input. So we don't have that. So that's why you input 1, input 2, you can swap position. It doesn't matter. Okay. Yeah. So that's why if let's say you have many inputs, every input is independent. So that's why basically fully connected layers and the models that we are learning today, they cannot capture what we call the spatial features in the input. That means the spatial features, that means the relationship between the input. Okay. Some data, the sequence is important, right? Okay. For example, the time series data. Okay. So the time series data, you cannot treat every data as independence. You need to follow the sequence. Okay. Another one is, for example, image is okay. Image is very much independence. But when it comes to video, okay, when we come to videos, video also follow the frame, follow the sequence, right? Okay. Yeah. If you want to understand a video, you have to watch the video, right? Continuously. Okay. If I cut the video and then swap the time between the different clip of the videos, I believe you cannot understand the videos, the movie. Am I right? So that's why this is one of the main problems or one of the limitations in the conventional fully connected layers. Okay. And also the models that we want to learn today, the CNN. Okay. So this kind of neural networks, they cannot capture the spatial relationship, okay, yeah, between the input, the sequence. Okay. Yeah. So invariant to transformations. Okay. So fully connected layer do not inherently possesses translational invariance, rotational, and other desired property of tasks where the input may undergo transformations. Okay. Yeah. So for example, in image classification, a fully connected layer may not be able to generalize well to images that are translated or rotated. Okay. So I think the definition is clear enough. Okay. Yeah. So again, for if we just look at data, that is okay. Data is just 1, 2, 3, 4, ABC. Okay. But let's say we want to process some other data, the multimedia data. Okay. So image. Okay. For me to recognize you, I can look at you like this. I can look at you like this. Even I reverse your image, I can still recognize you. Okay. But in fully connected layers, they cannot capture these features. Okay. They cannot capture this. We call the transformations of the data. Okay. So they fail to do that. So yeah, the model that we learn later can overcome these limitations. Okay. Yeah. So again, low efficiency is high dimensional input. That means if your input is very high dimensional, so such as text that we learn. Okay. So again, text, even image is high dimensional. Okay. So fully connected is not suitable for that. It's very inefficient. So that's why you will see fully connected layers usually at the end, at the other part near to the output. Okay. At the input, if you have high dimensional layers, usually you don't see fully connected. Okay. You see fully connected after the high dimensional characteristic of the input is overcome, or is not to say overcome, is reduced. Okay, so most of the time if you see the deep learning models, you still see the fully connected layer, but toward the right hand side, okay, toward the output. Okay, because we are kind of like already reduced the dimensionality. Okay, so yeah, and then yeah, difficult to interpretability. So that's why I say, I look at the neuron, the input, I say, you just sum them together and then do a sigmoid, and then you learn the features. Basically, the explainability is very low. Okay, so this is actually against is all. And again, I say previously it's fine that we do not know how the neural networks operate, because all this while we very much treat these neural networks or AI model as a black box. Okay, it's like what I teach in these subjects compared to what those who have taken Dr. Jiwan's machine learning. Okay, Dr. Jiwan opened the box, look at inside. I think Dr. Jiwan asked you all to code also, right? Yeah. So for me, I don't do that. Okay, I'm still okay. You treat as a black box, because my focus for this subject is more on application, using it. Okay, in different scenario, I will more on the cases. Okay, so it's more on application, I would say. Okay, less theoretical. So but again, it is a trend. It's a trend now. Okay, when you do research in AI now or in future, okay, they want what they call XAI. Okay, so they want explainable AI. That means they can understand how AI do the works. I think maybe they worried in future AI will kill us. So we better know there are a lot of science fiction, AI will kill humans. Okay. Yeah. So that's why maybe now they worried. They want to know how AI do the works. So that's why a very hot term nowadays is XAI. Okay. X stand for explainable. Okay. Or explainability. So that means we can even normal people can understand how the AI algorithms or how the AI models work. Okay, yeah. So yeah, it's a very popular terms now. So that's why even my PhD students, then they are doing works, I say, yeah, you should look into the XAI. It can be one of the novelty in your works, because previously we don't have a lot of XAI. Okay, so yeah. Okay, so yeah, that's all on neural networks. So after this, I will introduce the neural networks that we are going to study today. Okay, so we take a 5 minutes break. Okay, I think those who need QR code is here.
Whether the final exam will be focused on application of the
Okay, later I will do revision. Don't worry, I will tell. Okay, yeah, it's more on applications. Okay, yeah, later. Okay, yeah.
by the way, as you mentioned, Lucy, you see the ability that stems from the actually that has you see
The brain, right?
yeah,
Yeah, yeah,
correct.
yeah.
As the people you see when they do the meditation or yoga or
Yeah.
when their brain signal get to follow the alpha waves, and they start to develop some uh telepathy, some superpower.
I yeah, I don't study on that, so that's why I really don't know about that. Yeah, yeah. I did yoga a long time ago, but I never developed superpower also. Yeah, again. Uh-huh. Parking. Don't park there actually. Yeah, of course, no parking. You cannot park also. You go and apply sticker. Yeah, then you cannot drive. Yeah. Yeah, it's supposed you don't have car sticker, you cannot drive. Actually, you see, the guards a long time ago, they really blocked the car. Without car sticker, they don't allow to enter. But that make the whole PJ jam, not just inside, also jam outside, So that's why the police come and say you cannot check car sticker. Yeah. Mm. Yeah, they don't allow. Yeah, they will climb. Yeah. Yeah. Uh-huh. So you better grab. Yeah. Sorry? You park near to LRT and drive and take LRT. Yeah. Even we don't drive to exam hall. But luckily we are near. So that's why I walk to exam hall. Luckily we are near lah, We don't park, we don't drive to exam hall. It's very jam. Even I walk, I think 10 minutes I can come back to office. Long time ago I drive half an hour, I still stuck there, I cannot come back. I feel like I want to just park my car and walk back. Yeah, even lecturer we don't park. We don't drive there. Yeah, even some lecturer from even other faculty they walk. Yeah, because the traffic will be horrible. Okay. Yeah, especially yeah, your exam is together with undergraduates. Yeah, very bad. Yeah. Mhm. Okay, let's continue. Okay, so we have no bell here. So when I was teaching in China, I think same, right? 45 minutes. they have a bell. Is it the same in all university? So I feel like I was in school. I was like in school again. Okay, so yeah, but here no bell, okay, yeah. So let's continue. We have a short lecture on CNN. So again, like I mentioned, our focus is not on open the box and see what is inside. But you know, if I don't teach it, I don't know what to teach. So that's why I still cover a little bit on CNN. At least you know some basics on CNN. Okay, so who knows, it will benefit you when you do your maybe you do a PhD in future, or when you are started doing your projects. Okay, so yeah, CNN is one of the another fundamental basics models. Okay, so it has been there for really long times. Okay, so and so so it's a models that you know initially designed for image, because as I said, you know, previously when we use ANN, we do a lot of AI tasks in image processing. Okay, we mainly use for these image processing, you know, especially facial recognitions. That time I remember many of my classmates, they are doing final year project on image recognitions. Okay, recognize the face, recognize the objects and so on. Very, very primitive things, you know. Now it's so easy to do already. Okay, yeah. So you know, car plate recognitions, all these are the project 20 years ago. Wow, but it took 20 years. Because now you go to many car parks, you know, they just recognize your car plates. Yeah. But the idea is really from about my time, you know, 20 years ago. But now only is really widely deployed. Okay. So and they noticed that these fully connected layers, or the we call the multi-layer perceptrons, or the neuron models, is not very suitable for image. Okay, it's not very suitable for image. So that's why this CNN is very much, I would say, is a very major evolutions in the neural networks. Okay, so they especially use it to target the image. Okay, to use it to target the image. So yeah. So one of the key difference is that the neuron are organized into three-dimensional. Okay, so it's not what you see just now. Okay, yeah. So the spatial dimensionality of the inputs, okay, will include the height, the width, and also the depth. So the depth, sorry. So they are kind of like make it a three-dimensional models. Okay, so yeah. But we also have 2D CNN and also 3D CNN. Okay, three-dimensional CNN. We also have two-dimensional CNN. Okay, so again, the depth here is not referred to how deep is your neural networks, but it's referred to the input, to the three dimensions of the input. Okay, yeah. So and then again, you know, it's different with ANN also, you know, fully connected. CNN is not fully connected. So CNN, they try to target different part or different regions in, if let's say image, in the image. Okay. In other words, they try to capture different features. Okay. They try to capture different features. If you see fully connected, we have every neurons. We try to capture all the features of the input. Okay. And then by going through multiple layer, hopefully we can learn all the features. CNN is slightly different. We kind of like, you know, distribute the task. Okay. Distribute the task. Every part of the CNN, they target on different regions on the image. Okay. Or of the input. So in other words, they try to capture different image, different features. Okay, you can imagine like this. Let's say you want to do a facial recognitions. Okay, we can have one part of the CNN just target on the shape of my face. Okay, yeah. So there will be some other part will capture, for example, the eye part. Okay, some will capture the nose part. So yeah, they are doing that. They try to target different features in the input. Okay, so that is yeah, what you, yeah. Okay, so how to do that? Okay, how to do that against, you know, this part even I study so long, I feel like I think I understand, but I still don't know how to explain, you know. So yeah, the easy explanation is they use different layers. They use different layers. So the convolutional layers and then the pooling layers, and then they still have a fully connected layer at the back. Okay. So they use the convolution layers to try to, like I say, to capture different features. Okay. And then they use a pooling layer to reduce the dimensions so that, you know, when you go to the fully connected layer, it's not high dimensions already. Easy to understand, right? Okay. But at the end, how come you can detect the image? I still cannot understand. Okay, I understand how every feature, every layer, how they works, and I understand the logic is quite easy to understand. Okay, but then I just tell myself, okay, then I will get the expected output. Okay, yeah. So okay, so again, in CNN, the main contribution is the introductions of this convolution layer and pooling layers. Okay, it's a very creative ways to extract different features and then kind of like compress it, reduce the dimensionality so that, you know, the complexity can be reduced. And it's still very efficient. Okay, it's still very efficient. So that's why you will mostly see the architecture like this. Okay, you will have a convolutional layers, you will have a pooling layers, and very often they will have convolution again, pooling again, convolution again, pooling again. Then at the end only fully connected. Okay, so you can imagine that they are trying to, I would say, fine tune and or make it more and more sensitive to extract the features, or more and more accurate to extract the features. Okay, yeah. So later you see a different models that is based on CNN. You see very deep, right? You see convolutions, pooling, convolution, pooling, maybe partially fully connected, then convolution again. So that's why I do not know where is the. Of course, they claim that is a novel model. Of course, it's a novel model, but I always have difficulty to understand why you put something here and then why you put something here and then you claim that they will give you very good performance. Okay, but if let's say when we come to applications, you no need to understand. Okay, yeah, against YOLO, I think many of you, if you do assignment, I believe you use YOLO model. Okay, yeah. Yeah, they have many different versions. They are just making it deeper and deeper, adding more layers only to me. Okay, yeah. So yeah, this is how a CNN works. So yeah. So yeah, you look at the examples. So the input layers, of course, you still have an input layers, okay, to take the input. So the input layers, again, CNN is mostly designed for image. So this input layer will take the pixel. Okay. So the pixel value. So do you understand the pixel value? Okay. So what is the pixel? Yeah, so the pixel is the smaller part of the picture, right? If you take a picture, you make it enlarge, then you will see boxes. But at the end, what is that? You make it very big. You see one pixel, basically one pixel, one box, right? Yeah, actually, it's just one color code. Okay? Yeah, it's just a color code. Okay? So you know that different color, we have different color code, right? In internet. Yeah, so it's just that. So you can see an image at the end is just number, or at the end it's just 101010. Okay? So yeah, we put this 101010 into the input. So again, you know, color is like subjective, right? Yeah, but actually it's just numerical, it's just digital. Okay, so I look at you, it's like digital already now because you got color. So I should see you 11111010. Okay, so yeah, so the input layer, you will wonder, you know, how input layer take colors. Okay, actually it's just taking numbers 1010. Okay, yeah. Okay, so and then the convolution layers, okay, we determine the output of the neuron of which are connected to local region and input through the calculations. So there are some calculations. Why it's called convolutional layers? Because it's used the convolutions functions. Okay, yeah, it's used a convolution function. So that's why it's called convolutional layers. Okay, so Yeah, so basically it's a scalar product. So again, it's a vector that we learn in mathematics. Okay, so the scalar products, okay, of their weights and their region connected to the input volumes. Okay, so here they use a functions. Okay, so in CNN they may not use sigmoid. Okay, they can use sigmoid as well. Okay, because after all it's an activation functions. But in CNN we mostly see they use this Reynolds activation function. Okay, RENU, and they have many different variations of this Reynolds system as activation function as well. Okay, yeah, Leakey and some others functions. So again, what is an activation functions? Activation function is just you take the input and then you decided, okay, what is the output? Okay, so that is what we call the activation functions. And yeah, in this case, the activation function is just a maximum functions. Okay, so they take the maximum value between 0 and Z. Okay, if the value is smaller than 0, all becomes 0. Okay, if the value larger than 0, it will take that particular value. Okay, so yeah, that is the functions, the activation functions. Okay, and then what is pooling layers? Okay, as I say, pooling layer will reduce the dimensions. So that's why how it do is like quantizations. We do downsampling. Okay, we do downsamplings so that we can reduce the spatial dimensionality of the input. Okay, so this will reduce the reduce the size of your models. Okay, reduce the size of your models. Okay, after that you have a fully connected layers and connect to the output layers as usual. Okay, yeah. So yeah, what you need to understand is we use a convolution functions to target on different regions in the image, and then we use a pooling layer to drastically reduce the dimensions of the input. Okay, so this overcomes the problems in the ANN. Okay, yeah. So that's why if you want to create your models, you can create your own CNN model. It's relatively simple and straightforward. Okay, yeah, the code for convolutional layers, pooling layer is all there already. You can always play with adding more and more convolution layers. Okay, you can also have a few convolution layer then do pooling. Then it's quite fun to play. Okay, yeah, you can do that. It's all there already. Okay, yeah. So yeah, a little bit on convolution layers. So that's why you say you can see here why we call a convolutional layer, because it's the mathematics is convolutions. Okay, they do a convolution functions. Okay, here. So I think I don't want to cover in very detail. So I just look at the examples. Okay, so you can see this is how we do convolutions. Okay, basically we develops the kernels. So you can see this is I think this one is with animation. I think so. Yeah, yeah. So is it with animation? Yeah. Okay. So they decide on the the windows. Okay, for the kernel. So that's why these four. Okay, they will calculate and then they will do an activations. Okay, so let's say this is the kernels. So they will take this, multiply with this kernel. So that's why they will get the value 4. Okay, so you can see this whole, you imagine this as an image, and the output features will be like this. Okay, I'm not sure. Then you will continue this part, and this part. So the output features, after you go through one convolution layers or one of the nodes, it will become like this. Okay, so yeah, so this is what you will see. Okay, so this is what you will see. Okay, this is after I think after the first convolutional layers. So you have an input. Your input is the handwritten input. Okay, you will write 1, 2, 3, 4, 5. You can see after go through the first convolution layer, what do you see? What do you see? You see some like the stroke, right? But you cannot see number 1, 2, 3, 4, 5. Can you see? Some you look like you can see this one maybe is a 7, this one maybe is an 8 or something, right? Okay, but it's okay because this one is only one layer. Okay, one convolutional layer. So this is the output after you go through that. Okay, so that's why you may not understand why this become like this, but yeah, you just imagine the pixel and then you go through some calculations, it will become like this. Okay, so you imagine we have many different nodes in convolution layer. So they will target on different region. Okay, and when you combine together at the fully connected layers, you can see the numbers. Okay, so that this is like how it works. Okay, yeah, so you target on different regions. Some like they more on the stroke that is straight. Some their stroke is horizontal, vertical, or some other angle. Okay, they try to learn differently, and then remember you have a fully connected layer that you combine everything. That is where you can recognize the numbers. Okay, so you can see this is only, you can see here, you don't see much, but you can see some of the features in the handwriting. So the handwriting, I think, is this example. It's something like this. Okay, yeah, it's something like this. You can see it's pixel. Okay, so after you go through the first convolution, maybe you just extracted this part only. Okay, yeah. So yeah, this is the convolutional layers. Okay, after that you have a pooling layer. The pooling layer also very much depends on the functions. For example, you have a, I'm not sure you heard, okay, some they call a max pooling. Okay, max poolings mean the pooling layer, they are using a maximum functions. They will calculate the maximum. Okay, they will calculate the maximum of the kernels. Okay, so you see, after I go through the convolutional layer, okay, let's say I apply a max pooling at this. Again, is a 2x2 panels. Okay, a max pooling means I will take the maximum value of this one. So then this whole thing will become 5. Okay, so yeah, you can see here. So again, this is after I calculated, so I look at the first kernel. So I will take the maximum 20. Okay, so it depends on what function you use. You can use a max, you can take also an average. You can calculate the average of this one and put here. You can also take the minimum of this one and put here. Okay, yeah, ultimately we want to learn the features. Okay, so different functions, they may give you different output, so we may want to test on different functions. Okay, so I think the most popular one that I always heard is max pooling. They will take the maximum value, maximum value, maximum value, maximum value, and reduce further. Okay, so yeah, I hope you can see, from the fully connected, basically you will have everything. Now what you can see is they are reducing the dimensions. Okay, yeah, they're reducing the dimensions. After this, let's say after this only connected to fully connected layer and get the output. Okay, yeah. So yeah, so we look at the evolutions of CNN. So these are all CNN models. So these are all very popular CNN models. So it started with it started in 1989. So you see, it's not very new also, Yeah. So 1989, I was in kindergarten. No, joking. Okay. But even that, I think this is before you were born, right? Yeah, we already have the convolution net. Okay. Yeah. And then the LeNet. Okay. Yeah. And then the most recent one, but actually it's not very recent also. AlexNet is very popular. It's still used now. Okay, AlexNet is still used now. And then yeah, we see a lot of VGGNet. Okay, yeah, VGG 16, VGG 64, I think. Yeah, some VGGNet is still using. Okay, GoogleNet I have not seen in many paper. ResNet, we see a lot of ResNet in I think ResNet and UNet is mostly in medical, if not mistaken. Okay, yeah. So and then we have DenseNet, that is even more dense. And yeah, I see recently I saw some paper using EfficientNet. Okay, so if you're interested, you can go and see. Actually, it becomes deeper, deeper, and deeper. That means more and more parameters. Okay, so these are the yeah. So if you see the first one, the ConvolNet, so this is the ConvolutionNet, the ConvNet. Okay, so you can see this is yeah, one convolutional layer, two convolutional layers. Oh, okay. So they don't use the pooling. Okay, so there's no pooling here. They just use convolutional layers and reduce to this one. Okay, yeah. So and yeah, these are all the activation functions that you can choose. Okay, there are many different type of activation functions. Okay, so yeah, if you look at this different net, you can see as I say, you know, when this evokes, you can see the number of parameter in millions. Okay, so yeah, so as you compare to transformer, the one that we use in text, ChatGPT and so on. So this kind of model is still considered very small. Okay, only about 160 millions parameters. Okay, this kind of model now is considered a small models. Okay, when small model, that means even your laptop can train. Okay, if you train a transformer, your laptop cannot train a transformer. Okay, yeah. Okay, so yeah, we look at some strength of CNN. Okay, so the hierarchical feature learnings. That's why I said you will see different convolutional layers. Okay, because they will learn in hierarchy. Okay, so from the input they learn the features and then they learn again. Okay, yeah, and then spatial hierarchies. Okay, preserve the spatial structure of the input. Okay, through the convolutional operations. Okay, the spatial bit structure, that means the positions of the input. Okay, so it's still not the temporal relations. That means not the sequence. Okay, not the sequence, but the spatial means the location, the physical space. Okay, so that's why they still preserve the locations of the data. Okay, yeah. So and then they allow parameter sharings. Okay, so where the same set of weights is used across different spatial locations. Okay, so you can see here as you compare to CNN NN. So you can see this is one set of weight, this is another set of weight. Okay, in CNN is very much like the weight is very much like the canals. Okay, you can reuse this at different positions. Okay, that means they can reuse the weight. Okay, yeah. So then you drastically reduce the number of weights because you will use the same weight at different places. Okay, so yeah, that is how we can reduce the number of parameters. Okay, so yeah, that is on parameter sharings. Okay, so translational invariance, that means when you rotate or when you flip the image horizontal and so on. Okay, you can still capture that. Okay, yeah, the CNN can still capture that. So that's why when come to, have you tried, if you use facial recognitions, if you turn your face like this, can your phone recognize you? Suppose can. Okay, because yeah, they allow all these translational invariance. Okay, again, I think features hierarchy is yeah, I think it's repeats. Okay, hierarchy features, local connectivities. Okay, so I think this is very much the same. They allow local connectivity to capture the features locally. Okay, efficient in high dimensional inputs. Okay, because it will reduce the dimensions and then to a fully connected. And then yeah, it allows transfer learning. So conventionally, we don't have a lot of transfer learnings, but because CNN is mainly trained for image, so you can see different image. They are very much have the same features. Okay, so let's say if you train a models to recognize animal, for example. Okay, to recognize animals. Okay, so basically the models is also suitable to do some others object recognitions. Okay, because they kind of like learns what to do when you want to classify objects. Okay, so what we need to do is we take the pre-trained models. The pre-trained models mean the model that we already trained, and then we use some new data to train it, okay, to learn new things. So that's why a model that can recognize animals, we can take some of your faces, you know, and then many of your picture that you put in your social media and train against. Actually, the model can be used to recognize facial instead of animals. Okay, so that is what we call transfer learnings. Okay, transfer learnings um, conventionally is mostly do in the same domains. Okay, when we say the same domains mean image. Okay, object recognition for image or segmentation for image, they are still very much the same domain, different tasks. Okay, but later, okay, the transfer learnings also can be used in different domains. Okay, for example, I have a CNN model that I train on image. I can retrain again and use it for text, for examples, or use it for time series predictions. Okay, so that one we call domain adaptations. Okay, so to me they are very much the same things. Okay, but transfer learning usually they are within the same domain. Okay, when we apply to a different domains, when we take a pre-trained models, try to use in a different domains, for example from image to text. Okay, we call that domain adaptations. Okay, very much the same thing to me. Okay, scalability. So yeah, it's quite easy to scale up or scale down. Okay, so in recent years, if you look at YOLO they have now they have YOLO 8 and then they have different versions. They have a light versions. Okay, and then I think they have another one is a full versions. Okay, that means it depends on how complex is the task that you want to do. They have a model that is of different weight. Okay, so different size. Okay, if let's say you use YOLO 8 for some task that is very simple, you can use the light versions. Okay, then you can deploy easily into a very simple or very low end processor. Okay, yeah, if you want to perform some very challenging tasks, okay, that require high accuracy, you may go for the full version of the YOLO. Okay, so how to do that? Basically, it's quite easy. Just reduce some layers. Okay, yeah, when you reduce some layers, the size of the model becomes smaller. But of course, you will compromise on the quality and accuracy. Okay, but doesn't matter. Some tasks, as I say, you do not need to have very high accuracy. Okay, yeah. So yeah, I think this is application domains. So again, mostly used in image related applications. Okay, image classification, object detections, semantics, segmentations. Okay, segmentation means you kind of like identify different regions, you know, or in the image. Okay, so yeah. Uh, and then it's also used in video analysis, but it may not be the most suitable model for videos analysis because CNN cannot capture the temporal features. Temporal features means the sequence. Okay, CNN cannot capture the sequence. Okay, so if you want to do video analysis using CNN, you have to do some modifications. Okay, we will come back to video analysis next week. Okay, and someone asked me whether the exam is physical or is application or what. You will see video analysis in your final exam. Okay, in your final exam question 3. Okay, yeah. So that's why, yeah. So, but don't worry, next week we will do video analysis. Okay, yeah. And then gestures recognitions, the position, okay, the humans movement. Okay, we also see CNN in natural language processing, but to me, it's not very suitable, but it can still be used. Okay, it can still be used in NLP. Okay, yeah. But a more useful or more suitable models is still RNN. Okay, it's still the recurrent neural networks. what we are going to cover next week. Okay, don't get excited. Don't worry. Next week I will talk again on video analysis. Okay, don't get excited. Yeah, and also we can use CNN in gaming as well. Okay, so these are some of the application domains. Okay, so yeah, I think yeah, I give an examples on very basics CNN. I think only one convolutions, one pooling, one fully connected layers. Okay, so for object recognitions. So if you look at the codes, I think the accuracy is not very high. Okay, the accuracy is not very high. So that's why you may try to add more layers. Okay, and improve the accuracy. Okay, yeah, you can true, because I think the code I use is a very basic models, one convolution, one pooling, and then fully connected. So that's why I think the accuracy is I think it's about 60-70%, if not mistaken. Okay, yeah, you can try to run this, you can try to add more layers and then see whether you can achieve even higher accuracy or not. Okay, so for this. Okay, so yeah, so that's all for these chapters. Okay, so next week I will cover RNN. Okay, and then we'll look at the applications, and next week we will discuss on the videos analysis. Okay, which is related to your final exam question 3. Okay, but you will not know what's questions, so we will do that next week. Okay, I think now we take a break. We take a 15 minutes break, and then we will do revision on question 1 and question 2 of your final exam. Okay, on the text analysis and also the what we do, NLP. Okay, so we'll do that after the break. So I come back 1:45. Okay. So we'll look at the questions from past year. Okay, first. Okay, so yeah, I believe some of you have tried the questions. Okay, so yeah, I think 1, 2. Okay, number 3. Okay, so this is a questions on time series analysis. So you are given a traffic information. I think someone sent me the answer for this one, and he just used these 2 data for ARIMA. Don't know. Okay, so yeah, you can see this data set contains 4 fields: the dates and the times, and then junctions ID, number of vehicles, and then a Unix ID. Okay, what is the unique ID? Oh, so it's the ID for the data set. Okay, so yeah, you just imagine you have a huge data set like this. You have a huge data. Did I switch on the mic? Yes, right? Okay, yeah. So you have a huge data set like this. Okay, so these are the informations. So yeah, I did not give you more. So that's why it's suppose the junction ID, you will expect that there will be a lot of junctions. So that's why I give you a part of the data set, but you need to knows the data set a little bit. And quite often, my question is more open-ended, or you can say that I don't give very detailed information sometimes. Okay, because why? Because it's I'm very lazy. Okay, no, because I want you to make assumptions. Okay, because in real applications, in real world scenarios, right, you are not always getting perfect data, or you will not always have people tell you these are the things that you must do. You as the data scientists, I would think, or or the engineers solving the problems, sometimes you have to make assumptions and you have to make decisions. So that is included in my assessment as well. Okay, so that's why very often the students that's why students undergraduates, they like to ask other lecturer many questions during the exam. So that's why other lecturer always complain to me, I walk non-stop 2 hours, this student ask me question, that student ask me question. But I can tell you no student ask me questions because they know that I will never answer their questions. My answer is always make your assumptions. Okay? Yeah, there's one time the student say, sir, your question is wrong. It's wrong, then you just follow the wrong questions and solve the questions. Yeah, make your assumptions. Okay? So that's why eventually the student tell their junior. So that's why I'm very relaxed during the exam. So nobody asks me questions. Yeah, because even they ask, sir, this is wrong. Then you just answer the wrong question that I said. Make your assumptions. So that's why don't ask me questions during the final exam. Okay, I will very much ask you the same. Tell you the same thing. But of course, if you really got a question, ask lah. Okay, but yeah. Okay, so that's why a lot of things you need to make assumptions. So that's why this data set, some of the things that you want to think is, how big is your city? Okay, yeah, is this data set contains the information for the whole city or just one local area and so on? Make your assumptions, yeah. So yeah, and then the number of vehicles, okay, yeah, at the particular junctions. So I believe you can imagine, let's say, I just assume a residential area, okay, and I'm just taking the traffic at the main junctions, okay, in an area, okay, or I can imagine this is a city, okay, like PJ area. So I would just look at the junction at the major interchange, okay, of the junctions. Okay, and then I will ask myself from here what I can do, because you see, even you do traffic prediction, you don't predict traffic at every single junctions. Okay, you just do the prediction at the major junction of a city, and then basically the traffic flow in that particular city. Okay, yeah. Just now your friend asked me, during the final exam, if I drive, where should I park? I cannot help you. If technically, if you do not have a sticker, you are not supposed to drive to Okay, so yeah, because yeah, if you park, you will claim, and then how much they charge now? 100. How much they fine? 100, is it? Yeah, okay, yeah, they will fine you, especially during the exam period. Good income for them, for university. Okay, not for personal. Okay, yeah. So it's good to grab. Okay, yeah. So that's why because you see, last time our security used to be very hardworking. They stop every car at the entrance. If you got no sticker, they will ask you to U-turn. Okay, and because only we are checking this car sticker, right? You know how bad is the jam in the whole PJ area? It jammed all the way to Subang Jaya and to Klang. Then the police, the traffic police come and discuss with our TNC and say, you cannot check car sticker. You have to let the car in. Because there are many cars, they just use a shortcut from KL to PJ. If we block that, actually it's affect the whole Selangor, Yeah, yeah. So that's why when this kind of traffic prediction model, we don't have to look at the traffic at every junctions. I would just say that it's the city, the main junction in a particular area. Okay, so yeah, so that's why when you see the question, you create some scenario for yourself. Okay, I always say you create some scenario for yourself. If it's not clear, you write down the assumptions that you make. That will help you to answer the questions. Okay, yeah. Okay, so that's why number one, when you have questions, before you start writing, think of the scenario of the questions. Okay, I can tell you most of the time I will not give you a very clear scenario because I want, hopefully everyone will give me different answer when you have a different assumptions. Okay, so yeah, okay, so that is the thinkings that I want you to have. Okay, next we go back to the technicals. Okay, you want to design, it's actually quite straightforward. You want to design a traffic prediction models. Okay, and in that chapter we only learn ARIMA, so definitely only one models that you will use. Okay, based on this data set that you have. Okay, yeah. So that's why that's always the questions. Okay, so that's why I also give you some hints. So that's why if you look at the lecture notes, you will have to explain the design from, again, it's a little bit like the data analytic life cycle. You look at what you need to do at every stage of the life cycle when you do the solutions. Okay, so that's why at the pre-processing, data pre-processing, the data explorations, okay, the model selection and trainings, okay, and then the model evaluations. It's everything in the lecture notes. Okay, so yeah, 10 marks. Okay, everyone can do. Okay, so that's why now it's time for exercise. You don't expect me to show you the answer. I don't have answer. Okay, yeah. So that's why can you work in a groups? Okay, I give you maybe 20 minutes. Then I will ask. I think most of you got computer, right? Yeah, I will ask you to show your answer. Okay, yeah, you can work in group now. Okay, I think yeah, I think 20 minutes. Okay, yeah, see how much you can do. Okay, up to you lah. Okay, yeah, you don't tell me the whole class one group lah. Okay, yeah. Okay, you all can discuss and now you can make noise, but I don't hear much noise. Okay, yeah. And again, like I say, try to be specific with the assumptions that you make relate to this case, traffic predictions. Okay. Yeah. And yeah, try to be specific. Okay. So it's here, right? Okay. Yeah. The case study, where's my case study? Ah, podcast. Okay. Yeah. It's related. Hey, where's my case? This is a case study. Yeah. This is the case study. Yeah. Yeah. So study carefully, there's a lot of assumptions that you need to make when it comes to these traffic predictions. Okay, later I will see. I don't want to give you too much hints. Okay, so these are the questions. The questions is spectrum up again? Is spectrum still down? Still down? Oh, okay. Yeah, then I think you didn't download the question, right? The question is in spectrums. Okay, I posed this question in spectrum long time ago. Okay, yeah. Okay, so later you make sure you write a answer. Then I will tell you how much mark I give to your answer. Then you will know how I do my marking. Okay. So if you got no answer, then I will not tell you how I mark. Okay, I think some are online, right? Even the online one, I hope you can do it yourself. Okay. Yeah, I think the online. I'm still online, right? Yeah. Okay. Yeah. Even those online, if you're not in the classroom, please, try to do it yourself. Okay, anyone finish? You can just yeah, upload your file here. And then we check together. Okay. Yeah, I can give you another like 8 minutes until 2:15. Okay, if no answer, then I won't discuss. Yeah. So make sure someone post something here. Okay. You know, in MS Team, okay, you go to file, you just upload your file here. Okay, then I can open. Aiya. Anyone got answer? Have you anyone uploaded? Oh wait, okay, good. I expect that group. Okay, good. Okay, yeah. So you ask me to wait, then I wait for you. Okay, good. Okay, make sure you send. Other group also, please. If you got, you can just upload. Oh, okay. Identify and define. Okay. Oh, Sama stand here. Okay. Yeah, later we can have a look. How to open this? Okay, good. I already got one answer. Okay, so later I will check. We'll check together. Okay. Yeah. Yeah, okay. Yeah, thank you. So Sama already sent. Okay, we wait for another one. I wait for that group. That group say want to submit. Okay. Yeah. Oh, actually you can send here. I can. Yeah, okay. Okay, so when you submit the answer to me, when I comment, please be open-minded. Don't get upset. Okay, yeah. So we are learning. Okay, and yeah. Okay, and don't laugh on your friend answer. Maybe your answer is also not much better. Okay, so we learn together. So it's good. We learn from example. We learn from mistakes. Okay, yeah. We wait for one more. Okay, yeah. I have to wait that group to finish. They promise they want to send me. Other group also, please, if you want. Yeah. I think you can just send here, then I can open straight away. Yeah. Okay, so I got two already. Okay, so anyone else want to give? Okay, so yeah, let's look at this answer. Okay, so yeah, um against everyone be open-minded. Okay, so when I comment, so you see, when I look at this question, this answer, I would it's rather difficult for me to understand your mind, because you see, when I ask a questions against, it's also how you answer the questions. When you answer the question, actually you want me to understand your answer, right? Yeah, because if I don't understand, I cannot give you marks. So that's why you really have to think, not just my questions, any questions. And furthermore, this is an open books. So really all exam is open books. You keep in mind that open book exam doesn't mean that your job is just to go there, find which page to copy the answer into your answer script. Okay, because even for undergraduate now we start open books. Okay, when we interview the students, we ask, why open books you also cannot do? Sir, not enough time to search the answer from the textbook. That is the answer that the student give us. Yeah, so again, open books is not about searching the textbook, copy the answer into uh your answer script. Okay, for this subject, I will say that the open books mean you do not have to memorize the step. Okay, you can open the textbook and know the step, and then you will do your work. You still have to things, you still have to have thinkings and solving the problems. Okay, so that's why one thing is you need to let me understand your answer, and make sure when you write the answer, you are answering the questions. You are answering the questions. Okay, the answer asks you to design a traffic prediction models. Okay, and then you explain your design based on the 3 stages. Also, I would say that I will start writing like okay, to design these traffic prediction models based on the traffic conditions. Okay, so yeah, you see, when you read here, actually, I don't understand what you want to tell me, right? Do you understand if you look at this answer, what you try to tell? At least you write in a proper sentence, even, you know, even that, it's not a full sentence, write in a brief sentence that I can understand. Okay, yeah. So first, honestly, I don't understand at all. So that's why, yeah. Okay. So that's why I rather difficult here. Okay. So yeah, you see all this the data, but the data are already given. Identify data needed, but you don't need to identify data needed because it's here already. These are the data available. Okay. So yeah, and then yeah. Okay, then we go to the step. Okay. So you see, these are actually, I would say this is almost everything in the lecture notes that you copy. Okay, so I don't see very specific. For example, you can see aggregate data over appropriate time interval, example minutes and hour. I don't need this. This is my lecture notes, I would say. Okay, if you want to do that, you tell me. I will aggregate the data over every hours. Okay, I really don't like to listen to my voice. Okay, so that's why you see your answer will be I will aggregate the data over every 1 hour. You see the difference or not between this sentence and what you are doing? Okay, yeah, can you not take my videos? Okay, yeah, and don't post in TikTok. Okay, yes, that's why I say I think it's good you listen and try to understand. That is more important. Okay, yeah. So that's why I would see all this is very much copy from the lecture notes because you are not solving. Okay, or you will say I will try the approach to aggregate the data over. Actually, there's no point for you to aggregate over every minutes, right? For traffic. Okay, yeah, you can say I will aggregate over every 30 minutes or 60 minutes. Yeah, you can do that, and then you will try which one will give you more accurate answer. You see the difference or not? One is your solution. One is like a lecture note instructions. Okay, so that's why I will not give marks for the lecture notes instruction like this. Okay, yeah, because you when you decide you want to do something, you decide on how to do. Okay, you say, okay, I will do aggregation data over 30 minutes and over 1 hour. I will try on these 2 models to see which one is more efficient. Okay, if you write like this, I will give marks for that part, and then I will give some bonus marks when your mark is not full marks, because from there I see some additional things that is not in my lecture note but is from you, right? You are trying to test on some other models. Okay, yeah. So yeah, this is one examples. Okay, yeah. So yeah, and then plot the time series is the plot always, is the plot show trend or seasonality. The series is not stationary. Okay, make assumptions. Okay, so again, here a little bit based on your knowledge. I believe you see, furthermore, this is a not very specific engineering case, right? It's a little bit like some common knowledge. Yeah, you're supposed to know the traffic trend, and you can kind of know whether this data is stationary or not stationary. Am I right? Yeah. Okay. You know the traffic conditions, right? But again, it depends on the assumptions in which city that you make assumptions. Maybe in your hometown, rural area, there's no car. Okay. The junction is always no car or one car, no car or one car. Okay. Maybe the whole kampong only one car. So that's why you need to make assumptions. Where is these locations? Okay. Yeah. And yeah, so that's why you see, if non-stationary apply detrendings, apply differencing, okay, again, this is lecture note, right? You don't have to apply two methods. You just need to apply one method. Tell me how you do that. Okay. So that's why, yeah, if let's say I check this one, this thing, I will give this answer 5 out of 10. But of course, later I will go and check properly where I can give mark. On my personal, general impression on this answer, I suspect this answer is from ChatGPT. Sama, is it? It's look, I didn't make accusation. It's look a bit ChatGPT to me. Okay, this answer I will say is about 5 over 10. That is where you will fill these questions. Okay. 2 point, 1 point is I don't see you solving the questions as instructed. Okay. Another one is yeah, it's mostly I would say from lecture notes. So that is why that is my marking. Okay. And then you will say, sir, which 10 point I need to put in, because it's 10 marks, right? Okay, I will give. So that's why I was, for these questions, I will mark in such a way that if you follow the whole process in the lecture notes, the step, but you tell me what you do. Okay, I will do differentiating for once time. Okay, and then we supposed to obtain stationary traffics. After that, I will calculate the PSDF and so on. Then I decided this is the second log or the 3 logs. You mix, you tell me the answer straight away for that. Okay, if you answer everything of that, I will give you 8 marks out of 10. So where are the 2 marks? The 2 mark is I want to see. That's right. Even when you do that, maybe there are 10 or 11 or 12 steps. You have all the 12 steps, I give you maximum 8 marks. Another 2 marks I will give to those involve critical thinking. For examples, in this example, what I can think of, one thing that I can think of, okay, junctions, and then vehicles, and then 0, 1, that is the time. I'm taking this every hours. From here, I can see I'm taking this traffic every hours. So 0 is midnight, 1 o'clock. So that's why I will have to start thinking, maybe I will just plot a graph how it looks like for junction 1, and then junction 2, junction 3, junction 4. If I can tell you, if I straight away, if let's say I take from all the junctions, like some are major junctions, I can have really a lot of vehicle, but some are really a junction just right in front of my house. You can see the traffic will be very different. Okay, so I will definitely do one step. Okay, it depends on what models, what prediction I want to do. I'm doing predictions for the major junctions with heavy traffic, right? The junction right in front of my house, there's no car. Why I want to do a prediction model? No point. I will first filter out this data set for only very busy junctions. I will not do for all junctions. Because if you do for all junctions, I forgot to bring my marker pad. You will see some are very, very high, very low. Some they are very low. Some they are very high, So if you feed this data into the model, you will never get an accurate model. Okay? So that's why I will filter out. I will just take junction with high traffic and I put it. If you got the answer, I will give you the extra 2 marks for full marks. Okay? Because that really involves critical thinking and analytical skill. And maybe your knowledge domain as well. But this is common sense. Okay? So without that, so my logic of marking is without that, you still get A. Okay? Yeah, but you just get A. If you know the process, yeah. So A and A plus no difference, still 4.0. Okay? But if you do this question very well, you will get extra 2 marks. Maybe it will help you in some other questions that you are not doing well. Okay? Yeah. So that's why you need to be brave is making assumptions. Some you say, oh, it's not in the question. The question only got this. That's why feel free to make assumptions. Okay. All these are required. Okay. Yeah. So we look at the second one. See, I can give 10 marks or not. Okay. Where's the second one? I thought I opened already. Where is it? Oh, got a lot. Sorry. Then I will just do one more. Okay. Okay. Yeah. Clean the data. Okay. Yeah. Standards. Okay. Yeah. So again, you see, it's still very much you are describing. Okay. Actually, for this answer, will you see seasonality in this data set? What do you think? Yes, right? What is the seasonality? What is the period? Sorry? Yeah. But when we talk about seasonality, it's a period. If 1 year is 52 weeks, 1 year, 12 months. So for this one, what will be the seasonality? 24 hours. Yes. The traffic hours are the traffic conditions for weekday. Mostly you will see almost the same every day. Or I can take a seasonality of 7 days. Yes. Because 7 day I will include the weekend, because the weekend traffic and the weekday traffic will be different. Okay. So that's why if I take 24 hours, I may want to eliminate the weekend. Then I will have a consistent every day. I will ignore the weekend. If I want to include the weekend, I will put 7 days, my seasonality. Up to you. Then you just explain that. Okay. I would use the seasonality of 7 days because I will see that pattern definitely. Okay. But of course, sometimes you will have public holiday during weekend, during weekdays. Am I right? Yeah. Actually, those are okay. You don't have to eliminate that. Okay. That is okay. That will actually add noise to your models. Then your model is more accurate because sometimes you will see the traffic. You see the traffic. You see sometimes the before the weekday holiday. Actually, the night before, right? The day before, maybe at night the traffic will be very bad. Many people going out for clubbing or whatever. You see, those maybe can capture in the model. So that is fine. Okay. Yeah. So that's why you need to have all this. So this I still see, yeah, maybe, this is a little bit better, got a little bit of analysis. I would say, maybe it's about 6 or 7 marks. Okay. What is lacking? What is lacking is not specific. It's still not specific. Okay. Yeah. So yeah. So I will not do the rest. Okay. Yeah. And okay. And next week I'll be quite busy. So that's why please don't send me your answer and expect me to check. Okay. But if you really want, you can make appointments, come to my office. If I got time, we can check together. I can check on the spot for you. Okay. But let's say if you want to come, maybe come in group will be better instead of everyone come in. Because next week I got a lot of presentations. I need to watch all your videos. I need to check the final year and the IDP, the third year design projects. Next week is very busy. Okay, so that's why if you send your answer to me, I will not reply to you. Okay, you can come to my office, then we can check together if you want. Okay, so any questions? Any questions? Or you start thinking, oh, I will definitely feel how. Okay, try to. Okay, yeah.
Doctor.
Yep.
Yeah. Regarding the assignment.
Regarding the assignment, okay.
Yeah. For the model that we use, we are. I mean, do we need to use the model like neural network?
Okay, Yi Yang, you text me later about assignments. Okay, not much time. I still want to go through one more questions. Okay, yep. Okay, these questions. Okay, question 5, I exclude already. So this is another question on NLP. Okay, so yeah, this is another different question. You will say this question, to be honest, is slightly more difficult because it's kind of like, you need to answer the whole question as a whole and 10 marks. Okay, so this kind of questions will be easier because I break into small one. So you can see I will expect short answer for every sub questions. Okay, try to do this. So you see the previous question is more on the design, on the mechanism. These questions focus on the interpretations of the results. Okay, so you can see the questions that I asked is quite different. Okay, yeah. So yeah, okay. Again, the same. Okay, short answer. This one is short, so maybe 10 minutes. Okay, then you can try to share your answer, or maybe not 10 15 okay, 15 minutes Sorry. Sorry. That's all. ABC only. Question 4. Okay, yeah. Okay, is this the first one or the second one? Okay, this is your report, is it? Oh, okay. No. Okay, why you send here? Okay. Okay, so I'll give you another like 5 more minutes, and anyone want to share the answer, we try to see. What's this? Okay, so I think for these questions, it's very much almost everything is in the lecture note. Okay, so again on how you explain your answer. Okay, so it's toward the last part, the sentiment part. Okay, so I think the first question is rather straightforward. You just calculate the percentage. Okay, so for positive is about 55%, and then negative is about almost like 38 or slightly less, 37%, and then the neutral is about 10%. Okay, so yeah, what conclusion you can make from here? So very often they just stop there. Okay, the conclusion is the positive is 55%. Example, you calculate the percentage, and then the negative is 37%, and then the neutral is 10%, and then they just full stop there. Okay, so yeah, so that's why you still have to make some conclusions. Okay, based on the questions. Okay, so you can make a conclusion that generally, the user are satisfied with the update, right? With the new release. Okay. I think this 2 mark is very much like a bonus mark. Okay, everyone can get. Okay, and then of course the B and C will be require some thinking, but as I say, the answer is already in the lecture notes. Okay, give your opinions on whether the analysis done is useful and comprehensive enough. Okay, so again, it's open-ended, but I would say that the outcomes actually is not conclusive enough, because the number of negative and positive and negative actually is quite close. Okay, and the number of neutral is also quite high. It's about 10%. Okay, so yeah, so that's why that's why there's no fixed answer. My answer will be, the conclusion is not very conclusive. Okay, So it's lack of comprehensiveness. If we just look at the positive and the negative features, sentiments. Okay. So if you look at the lecture notes, you will see that basically it's good that, you know, if we can include this part. Okay. For examples, we will do a classifications on the positive and negative sentiments. For example, the classification on positive sentiment, what features they like on, you know, that, or what are the classification of the positive one. Is it the time? Is it more user friendly? You know, because it's a social media platform. Okay. Yeah. And then on the negative, what they don't like, maybe a lot of advertisement. Okay. Yeah. And some other features. So that's why if I have that, that would be better, or some of this kind of analysis. So that's why it's there in the answer for the second part. Okay. Yeah, actually that is C already. Okay. If a more in-depth understanding on the user feedbacks. Okay. So additional analysis, I would suggest a classifications on the positive and negative sentiments, so that we know specifically what they like and what they dislike about the new release. Okay. Yeah, I think this question is more straightforward. Okay. And what is the expected outcomes? The expected outcome is what I say lah. Okay. We have a clearer understanding on what is liked and disliked by the users. Okay. Yeah, I think this question should be easier. Okay. So yeah. So that's all for these two questions. Okay. Now got more hints for you. Okay. You still have these two questions in your final, question 1 and question 2. Question 1 is still a prediction models and is engineering based. Okay, I cannot tell you which engineering. So you go back to all my engineering topic that I give, those one of the topics is on predictions, definitely predictions. Okay, the second one that is on the NLP. The first one is on the time series. The question 2 on the NLP is slightly different case study. So that's why I tell you what case study is on chatbot. Okay, yeah, chatbot. Okay, anyone know what is chatbot? Yeah, it's a chat robot. Okay, yeah. So go and do a little bit reading on chatbot. Chatbot use a lot of NLP. So the second question will be related to chatbot. So make sure you understand what is chatbot. Okay. Yeah, I think that's all for today. Okay, so I will see you next week. Next week I will give you question 3. Okay, what is the question 3? I already tell you. Question 3 is on videos, video analysis. Okay, using deep learning. But next week we'll talk more. Okay, so I think that's all. I see you next week. Okay.